Okay, we're going to get started. I'm going to let people trickle in as we get going. Thank you everyone for joining us for our first October DataWorks Maryland meetup. I'm extremely excited to have Anthony and Alberto from Esri, I believe, talking about wrangling data and visualizing patterns with Python and GIS data. So we've been in discussions for several months about this, and I kind of got to see some of the work that they were doing through their website and some other slides and talks, and it's really interesting. There was a lot of excitement and a lot of people interested in hearing about what they're doing. I think this is going to be a pretty cool talk because it's definitely a mixture of slides and code samples and interactive, which everyone always likes. So before we get started, I'd just like to thank our sponsors. If you see me stop for a second, I'm still clicking to allow people in the room. And then we'll go over a little logistics real quick, and then I'll hand it over to Anthony and Alberto. So first up is Veron Technologies. They're a defense contracting company in the Maryland area, focused on software engineering, data science, supporting some of the local agencies. So if you're interested in learning a little more about some of the work they're doing, you can reach out to me, or you can reach out to the information on the screen. Clarity Business Solutions is another defense contracting company supporting the local clients. They also do a lot of data science, software engineering, and if you're interested in learning more about them, you can reach out to me. ClearEdge is another defense contracting company. There's a theme here. They do some work in the area. They do a lot of data science, software engineering, big data. If you're interested in learning more, please talk to me. And then lastly, Areas Ventures. This is my company, and we are in a similar market. We're a lot smaller. So if you're interested in just learning more about the industry or what we do or anything, really, you can always reach out to me, and I can tell you what we're doing. So with that, just a couple things. So we have another meetup scheduled in a couple weeks focused on deep learning and healthcare. And then we're working on our November meetups, which is going to be on edge devices, and then a potential another event with FINRA. We do have a newsletter that goes out every month that has some interesting articles, and we try to announce other opportunities and conferences and events. All our sponsors are always hiring. They really help, us keep this going. And including the company that the speakers are from, really always consider the folks that are kind of giving back to the community. So with that, the last thing is for questions. The way that we're going to handle it, you can type it into the chat on YouTube, or you can type it on Zoom. I'm going to be monitoring the questions, and at the end, I'll be asking Alberto and Anthony all the questions. So I'll do my best to understand, but I might be asking you a follow-up just to clarify, but I'll try to curate the questions. So with that, let me introduce the speakers real quick, and we can hand this over. Alberto is a geographer, Python developer, and analyst working for Esri, who builds spatial statistics tools and helps GIS users find innovative solutions to important spatial problems, which sounds pretty awesome. Anthony is a senior level executive and team lead for Esri with a state and local government practice. So I think they do a lot of work locally, and they really, I think, are considered the experts in the field. Esri is the world leader in geospatial information systems, and they provide a lot of discovery, use, make, and share geographic data. And if you go to their website, they have a tremendous amount of information. They have some really awesome things. They have a lot of YouTube videos. They attend a lot of conferences. If you look up Alberto's name, you're going to see some really interesting talks. I saw one as far as a couple months ago on Python and using that with spatial data. So with that, I'm going to hand it over to Anthony, who's going to share his screen and take it from there.
Excellent. All right. I'm on mute and I'm sharing my screen, correct? All right. Thank you. Jason, thank you for the introduction, and thank you for asking us to present here tonight. Of course, we'd like to be in person, but virtual, I guess we can hit a wider audience, and I guess we're all dealing with this. So I'm working from my home. So is Alberto. So, we're dealing with this pandemic just like everyone else. And so we appreciate the opportunity to speak with you tonight. My name is Anthony Puzo. I'm based out of our Tyson's Corner office. And I work a lot with our state and local end users. So I work with more of the customer end of things. And Esri is a 50-year-old technology company, which is a bit of a unicorn in some cases. And we provide a mapping and analytics platform that's used by Fortune 500 companies, state and local government, major utility companies, gas, electric. A lot of the packages you get delivered by the brown truck and the orange and blue truck gets routed to your address using some of our technology. And it's just mapping is a backbone of a lot of the state and local governments that we serve. And it's a way for them to know where things are happening, how they can see things in real time. And they kind of use it across disciplines. So sometimes it's used in the IT department pretty heavily to integrate with business systems like a permitting system or a work order management system. But it's also used in like the public works department and the transportation and public safety and law enforcement. So it has a lot of different capabilities built into the platform. So it's not just mapping, it's actually data science and spatial analysis. And that's what Alberto is really going to get into today, is showing that data science and how that gets processed with other open source technologies and other open data sets. A huge, probably growing piece of our platform is really around field operations and how do I communicate to my people out in the field and get information back. Obviously, just mapping. Sometimes you just need a map, and that's a core piece of our platform. A growing piece is really getting into 3D technology, getting into that real world experience, integrating with things like BIM and AutoCAD and bringing in that design space. And then also taking that 3D information and maybe publishing it to gaming platforms like Unity or other gaming platforms, so you can actually bring real world experience to some of these games. A lot of our users look at imagery and remote sensing, whether that's imagery from planes or drones or other means of how you actually capture that imagery and bring that in to a remote sensing analytics, so you can drive out additional information products. And then the collection of a lot of different information. And what we provide is a GIS system. It's a geographic information system. It's just like all other information systems, except for that geographic component. We really specialize into that location, adding that XY component or that latitude, longitude component to the platform. And what we offer for developers is a complete mapping platform for all these different things. So we offer a wide variety of different APIs for 2D, 3D visualization, geocoding, directions, demographics. All these different things are built in our platform. And our platform is used for a lot of different means. Here locally, it's used to publish out data. So if you've ever been to some of the open data sites around state and local government, like this DC one, they're sharing over 1,200 different data sets here. And this is all built on Esri technology. So you can search things like trees or purchase car transactions or other things. And what you get with that is the actual live data set that the city's using, like their urban forestry street trees. So this is bringing in all of their street trees. You can see the data elements here. You can see when this tree data was updated. You could download this data in a spreadsheet, a KML, a shapefile, or you can actually write an open standard API to this, which is really flexible. And so this is very popular among our user base of how they get information back out. It's not just about sharing out a shapefile or a KML file. It's about actually providing the API for developers to leverage that and bring that into their own applications. So I encourage you to kind of look at that. And there's some really nice API exploring tools built into this. State of Maryland is no different. They have an open API. And one thing that they did really nicely here, and this is done by the Department of Information Technology, does an excellent job with their GIS system. And they aggregate a lot of the different data from all the departments, and they share this data out, like agriculture data or emergency management data or parcel information. And they share this information out into different segments. This is not just about data, it's also about sharing information products. And actually the entire coronavirus.maryland.gov site is all powered. It's hosted on top of an ArcGIS hub site. This is a technology that's included with ArcGIS Online, and you can build out these entire hub sites here. It's a Markdown JavaScript application here, and we can include things like dashboards. This is an Esri dashboard showing data at the county level, the zip code level, and then trends and what's happening in the state. So Esri also provides a ton of this information open source, so you can use this data at your fingertips. So this is our own COVID hub site here, and then we share out a lot of the data sets that you could consume as an end product, like social distancing metrics and social vulnerability and demographics. And so if you're interested in this kind of work, I'd encourage you to check out this hub page. But really what I'm going to get to today is how all those things are really driven by a Python API. So we have a REST endpoint that's open and available for you to use, this developer site that has a free tier for it, so you can go and start developing today. But what Alberto is going to do, and where I work with the end users, Alberto is the smart one, and he really helps bring all this stuff to life. And I think what he's going to show you today is how we can use the Python API and some of the data sets out there to really drive new patterns, new insights, and new information products to help do your job cheaper, better, and faster. So I'm going to hand this over to Alberto. He can introduce himself, and I think you're going to really enjoy what he has to offer you today. So Alberto, I'm going to stop sharing and then hand it over to you.
That's great. Thank you. Okay, so let me do a quick check. Can you hear me, see my screen, see me?
Yep.
Awesome. That's quite the intro. Thank you so much, Anthony, and thank you, Jason, for hosting us. And thank you, everyone. I sincerely hope you're doing well. It's crazy times out there. We're going to have some fun today, though. We're going to get into some interesting subjects, and I hope that whether you have decades or years of experience with Python, or you're just getting started, that you're going to take something meaningful out of this session. I don't expect you to remember every single thing I'm going to touch on. It's going to get a little complex at times, but if I lose you at any point, don't worry. Just hang on tight. We're going to get back on the train, and we're going to have some fun. We're going to keep it lighthearted and hopefully informative. And what we're going to get into is this concept of wrangling data and visualizing patterns with two of my favorite things, GIS and Python. So I wish I was in front of you in person so I could ask how many people have used Python and how many people have used GIS and see a raise of hands. Virtually, it doesn't really accommodate that type of interaction. So I would love to learn more about you. Hopefully at some point I'll give my email and you can reach out to me independently if you ever have a need to. So I do want to get started with that concept of wrangling. When I first heard about it, it really intrigued me. It's that word wrangling, like whether it's Jeep Wrangler or wrangling data or a cowboy wrangling herd. It kind of really well encapsulates the messiness of this part of our jobs, right? I think everyone that works with analysis, that truly does analysis, can empathize with how much time is spent in this part of the process. It's very often like the least illustrious part of the process. It's not the fancy, shiny object detection, machine learning, AI, buzzword, etc. But it is important. In fact, I would argue it's the most important part because many of us spend the majority of time here. Many of us spend maybe 70 to 80% of our time just cleaning up data, getting it ready. So I thought it was really important to kind of spend some time here and share some tools, share some best practices, hopefully, on how to do this. And then we're going to get into the interesting parts where we explore the data and get to do some fun stuff with it. So this is kind of a cold hard dictionary definition of wrangling data. I think we can start there, but very quickly, I want to point your attention to this type of image. And what I like about this is that very often people ask me, hey, how do you do analysis, or how do you do this type of analysis? And my answer, frankly, is I don't know, because it's a path that every person has to take individually. It's almost like your own little mini life story with each piece of data and each type of question that you're trying to answer. And it's much more akin to this, cow person, cow man, cow woman, trying to herd a bunch of cattle into some area, and there's no cooking list for doing that, right? There's no set structure to do that. You're sort of figuring out as you go, and it's as much a science as it is an art. It's as much gut feeling as it is book knowledge, right? So all of it comes together, and I do want to kind of point your attention to this type of image about data wrangling. And to do that, we're going to try to bring in some tools, and these are basically my three favorite concepts: Python, GIS, and spatial statistics. So I am a product engineer at Esri in the spatial statistics team, and we're going to get into some fun stuff towards the end once we have some prepared data and to try to assess some relationships and some interesting patterns. And what we're going to focus on today is actually, believe it or not, we're going to talk a little bit about politics. So, but not quite I'm not going to tell you who to vote for or anything like that. I think all of us are in the middle of this maelstrom. Really what we're going to talk about is voter participation, regardless of what stance you take, who you believe is the right candidate, etc. The premise that we're positioning here is that people should vote, right? Go out, educate yourself on the issues, and vote. And a lot of people throughout the country, throughout, a lot of nonprofit organizations, a lot of government organizations in general, trying to see this phenomena of voting. And in the United States, it's a voluntary practice. You don't have to vote. So voter participation is a crucial issue to study. And we're going to get into something like this, where we're looking at a map of voter participation across the country and start to get into some interesting patterns. But as I said, I want to spend some time in that crucial part where we prepare the data. So before we get into something interesting like this, we're going to start with just some bare data. And we're actually going to focus on a workflow to gather some tables, some raw tables of voter participation for each county in the United States, prepare it, and get it ready for some analysis. So the way I have it here, I'm looking at a notebook in what we call ArcGIS Pro, which is essentially our GIS workstation. And here we've recently introduced Jupyter Notebooks as an interface that you can use to do your coding or to do your data manipulation, etc. If you happen to know Python, then you probably are acquainted with Jupyter Notebooks by this point. And Jupyter Notebooks are really powerful because they let you not just write code, but they let you enter some descriptive text that help you communicate this information with other people or document your code, right? And that's what we have here. We have a Jupyter Notebook, and we're basically just outlining the steps to clean up some data, geo-enable it, basically bring it into GIS and give some geometry to it. And finally, geo-enrich it, which is where we bring things like the median age of the population there, the income, any characteristics about the people there that could be associated with whether they vote or not, and therefore we could build a predictive model or something like that. And we're going to step through this. Again, this is a lot of code, frankly. So if you don't keep up with it, it's okay. We can share these notebooks after the fact, and I'm going to point you to some resources towards the end so that you can follow it at your own pace. And in Python, like in many languages, some of what you do is basically build on top of other tools, right? So some of what we're going to do to get started is import some modules. So I'm basically running this cell with some code. And we're bringing in some familiar faces. So if you're doing some Python work, Pandas is a popular friend. Pandas, if you're just getting started with Python, my homework to you is go read up on some Pandas. If you're already acquainted with Pandas, great, welcome aboard again. And then additionally, you're going to notice some additional modules here, ArcGIS and ArcPy. These are Python APIs, essentially. One is for web GIS, the other one is for desktop GIS, essentially, or geoprocessing. We're going to use both of them here, and we've imported them. We've basically brought those tools into this workbench, and we can now get started on using them. And right over here, we're going to make reference to just the workspace that we have. So all we're saying here is let's go ahead and use this Pro project as our environment. We're going to point to a database that has some data or that we can deposit data into, and we're going to keep going. So actually what we're going to do is we are using a data set from the MIT Election Data Science Lab called County Presidential Election Returns 2000 through 2016. This basically has all the data at the county level. In the US, a county is an administrative boundary. So we can use that data, and basically we're going to import it here. And I'm going to read that data into what we call a Pandas data frame. So that's, if you're not acquainted with Pandas, a data frame is essentially a table in Python memory that you can quickly work with and you're quickly going to become best friends with. So this is what our table looks like, at least the first 5 records in that table. And what we have is essentially some good data. We have the year of the election, the state, the county, the candidate, and the party, and the total votes for that candidate. So that's a good start point, and we start to now assess some data quality checks, right? So the first data quality check may be that some of these fields may be missing some data. Pretty simple stuff, we're just gonna remove it. And what I like about it here is that with Python, you can be very customized to what you wanna see. So what we're doing here, don't pay too much attention to the code, just pay attention to the output here. I've basically created a print statement here that just records how many, or that prints out how many records have null values in an input field. So I'm checking the candidate votes field. In fact, I want to check, let's see, the FIPS field. I'm just going to change it up there and re-execute the cell. And for FIPS is basically your ID for each county, and it's crucial for us to get this right. There's about 64 records with missing FIPS, and that amounts to less than 1% of the data. So I'm just going to go ahead and remove them. But if there was a lot of records that miss that data, I may want to go investigate and fill in and see what's wrong with this data before proceeding, right? So right over here, I've basically executed the next cell, and that just removes those records that satisfied that query with null FIPS. Makes sense so far? Hopefully it does. And by the same measure, we can continue doing some data checks. We can continue basically appending zeros to truncated fields. So in this case, take a look at this last record here. FIPS is actually, even though it looks numeric, it typically is an ID and a string ID, meaning leading zeros should not be removed because they're part of the ID. But very often, as you're manipulating data back and forth from one system to another, one system may see it as a number, and numbers don't typically have leading zeros, right? So they get lost along the way. So that's a typical type of data operation that people have to deal with, and that can be problematic because then you can't use that ID. So in Python, basically, we can write ourselves a little helper tool to find that. And we can see I'm printing out the first 5 rows of our table, and this is Alabama, Autauga County, as well as Baldwin County. And FIPS are supposed to have 5 characters. So we can see that issue right there. We have a few, we have several counties actually with the leading zero trimmed out. And what we can do is basically check, once again, how many records does that amount to? Again, I'm gonna share this notebook, so if you're not keeping pace with the code, that's okay. But that does amount to an issue. Basically, we have about 10% of the whole nation that has this issue in our data. And what we can do in Python is, and kind of the reason why we go into scripting to begin with, is you're going to build yourself a little tool to address this in a very specific way. And the tool that we're building here is called Fix Truncated Zeros. It basically checks for rows where the FIPS only has 4 characters, and it's going to fix that. So here's an example. I'm going to pass to that tool that we just wrote up here 4 characters, 1121. Let's go ahead and execute it. Okay, it returns something with an appended 0 in the right way, and it's a string. But if we pass it something with 5 characters, it shouldn't do anything with this. It should just bring it back with the 5 characters. It gives it to us nice and clean. And then we can just go ahead and apply that to the entire column, and we see that issue corrected here. So we have leading zeros, and it's now a string. So these are some basic examples, checking nulls, checking basically leading zeros and data types. Here's a more fun one. Basically, the structure of the table is not really conducive to what we're trying to do. I'm going to go back to the animation shortly, but I want to point your attention to this table here. The rows are basically unique to the candidate. So this row is for Al Gore in 2000. This row is for George Bush in 2000. This row is for Ralph Nader. What we need in a GIS is each row to be unique to a county, and then to have the candidates be columns or fields for each county. So we need to basically pivot the table and do a little bit of data transformation. And that's actually what's happening here. I'm going to let the animation kind of play through. We're going to take all those rows and basically pivot them so that they become fields in our table, and then snap the county back into that table, and also append the right names to the field so that we can keep track of which candidate we're looking at and how many votes for what candidate. Hopefully that makes sense. And believe it or not, all of that is done by just this cell of code. If I execute this, basically we get the output in the format that we need. We get our unique county, we get the candidate Democrat, candidate GOP, and then the votes for each one. And what's kind of interesting about a Jupyter notebook is that, this did take quite a few steps, but you can use this notebook for education, right? You can basically break it out into, okay, step 1, we're going to use an index. Step 2, we're going to use a built-in group by function in Pandas, which helps us do this. Then we're going to unstack a table, etc. And I'm not going to go through the steps here. I think it's better for you to do that on your own time. But the idea is that if you open up this notebook and you really want to see how that pivot happened, you can follow along and copy and paste this code and use it for your own purpose. So we have our table. Let's go ahead and take a look at it once again. We have the counties with their FIPS all corrected. We've trimmed out some null values, much cleaner. We have the structure we want. We want the candidates as fields and the votes for each candidate as a field as well. We're getting there. We're also not quite there yet because we want to calculate some features or some fields essentially that will help us analyze voter participation. One of them may be the votes for a non-major party. And the way we're calculating that is basically the total votes minus the votes that went to the Democrat and the votes that went to the Republican. Basic addition and subtraction, right? So the way you do that in Pandas is actually fairly straightforward. And we've calculated that into a field here called votes other. And what's kind of interesting is that you can basically copy paste this code for other purposes. Right over here, we've done it and essentially gone crazy calculating a bunch of other fields that will make pretty interesting maps eventually. For instance, the voter share by a major party, the voter share by each party, or the raw difference or the percent differences between the parties. And that starts to get into some interesting ground when you're looking at swing states or swing counties even. And now we have all of these fields that we've calculated through Python, and each of those fields potentially will make a really, really interesting map. So we've gone through all this process where we've loaded data, cleaned it up, prepared it, calculated additional fields. We haven't yet made a map. So to make a map, we need to geo-enable this table. We need to bring some geometry and associate each record with the county that it belongs to so that we can make a map. And that's step 2 here. And this is where I point you to the Python API. Basically, we have WebGIS Python API that lets you authenticate with ArcGIS Online, or if you have your own GIS deployment in a server, you can do that. And what we're doing here is basically searching for a data set of USA counties. Or if you're doing this for a different region, you may want to basically search for published services, GIS services that other people have created that have the geometry, and you just need to join it using that FIPS or that ID for your administrative boundary. And we're making a query for that. However, pretty quickly I realized we don't just need counties, we need something with some information about each county, like the amount of people that can vote, because that's going to be our denominator in that voter participation calculation. We have how many people voted divided by how many people could vote. So thankfully, there was actually a layer that someone published called Citizen Voting Age Population by Race and Ethnicity, which is brilliant. This is exactly what we need. And this gives us that denominator in the equation. And we're going to formalize that as basically another data frame here in the notebook. So I'm reading it from the web right now. I'm basically making the query to ArcGIS Online, retrieving that data, and casting it to a variable called counties.df. Counties data frame essentially. So once we get that back, we can use this table and append to it the data from the elections, right? So here's our table. It has a shape field, which means basically that we can make a map with it. We have the geometry for each county. So we're going to go ahead and merge the two things together. We have a table with elections. We have a table with county geometry. Let's put them together. Now we're talking GIS. So here's our GIS table. We call it a spatially enabled data frame, but for short, let's just say a GIS table. And we call it GeoDF here as our variable, but basically it's all our data plus the shape of each county. And what's interesting about that is that now we can start to make a map. So it does have several years of election data. I'm actually just going to focus on the most recent election, 2016. And we're going to use that denominator, the amount of people that could vote, And in the numerator, we're going to use the total votes to calculate voter turnout. That's our big key metric that we really care about, how many people participated. So we have that there. We've only looked at it for 2016, and we're going to convert it to GIS. So let's go ahead and do that. And for that, I'm going to dock this over here to the right. Let me put it right over here, and I'm going to execute this cell, which is basically taking our table in Python memory, our data frame, and it's actually depositing it in my local disk drive as a feature class that this desktop GIS can read and work with. And a feature class, if you're familiar with GIS, that's something that you likely have used. If you're not familiar with GIS, it's just a common format that GIS folks use for making maps and analyzing maps. So it's processing the table right now. We're about to get a result here. And let me see, I think, yep, we got it right there. So here's our output table. And actually, I have it all symbolized by green. I'm not showing basically a value for any county, but right away I see an issue with this data. The big issue is a big glaring hole right here. In the middle of South Dakota, there's a county called Oglala Lakota. And this county changed names in quite a while back, actually. So let me see if I can show you the old name. Pardon me. So I'm going to open up this page. So this is a census web page that includes county changes. I think the point here is that you're going to have to do a lot of research when you're doing data prep and data engineering, right? You're going to have to get your hands dirty with some documentation from websites, from census, from whatever agency you're working with. And we see the issue here. Oglala Lakota County, it actually used to be named for a judge, and then there was a change to basically the tribe and the history of that county to better reflect the people that live there, which is important. And the change in the name basically could be subject to why we have that data issue. We may not be matching the two properly. And specifically, it's the ID here that we care about. So let's check. I'm going to do one more correction here. We're going to scroll up to where we put that table together right over here. And right over here, I'm going to enter some code. First of all, I'm going to title it Fix Shannon County Issue. And then we're going to enter a code cell right here. We're basically going to check, okay, our table, let's locate the records where the FIPS field equals, and let's check the value that it's supposed to be, right? So it should be 46102. Let's go ahead and pass that over here and execute it. Nothing comes back, which is a problem. It should be 46102, but it used to be 46116 when it was named Shannon County. And let me see if we can do that. Or I think it's 46113 rather. Yeah, there it is. Okay, so this is the issue. We have records with FIPS, with the old FIPS, but the new name. So it doesn't really match, and we can make that correction right here. Basically, I'm going to copy this cell, paste it right over here underneath. I'm going to clear the output. Whoops. There we go. So what we're going to do is we're going to change, we're going to say for this query, for whatever comes back, we're going to change it to be 46102, simple change. And now we're going to query one more time for the records that equal the old FIPS. Okay, they've been corrected. And now let's double check that they are the correct FIPS. And we've done the correction. So here's the old issue, correction, new data. And to finish correcting, we have to re-execute the notebook, but we don't have to write code at this point. We've already written it. It's just a matter of re-executing everything that we've done down here. Re-merging with the counties, bringing in the data from ArcGIS Online, and reproducing the feature class that we created. So what's neat about that is that because you've written the Python code, it's now formalized as a step in your process, right? It's not the next time you get this data or the next time someone duplicates what you're doing here, they basically just have to rerun it, and you formalize that step and something they don't have to worry about and they can even learn from, hopefully. So it's reprocessing the table, and hopefully we get our output here in a second. And really the true test is that that whole Oglala Lakota should be filled. So if I was there in person, I would do a drum roll, a mini drum roll, and we would get our little result here. So let's see, I think we're about to get it here in a moment. Let's give it a moment. My computer is doing a lot of work for me here. There we go. We're getting our output, and let's refresh our map. And the county is fixed. So I know that's a lot of data prep, a lot of code, but hopefully you start to see the point that basically Python can be a really powerful tool for preparing your data, for formalizing all of those steps and making them part of your process. So now all we've done is basically prepare data. We haven't gotten into the fun stuff. And now this is where we get into some fun stuff where we try to assess basically what's happening with voter turnout in the United States. So I'm gonna switch over here, and I've basically made a copy of that table here. And what I want to get into is some ways to start exploring this data through a GIS now that we've used Python to prepare the data. Right over here, we have our table that we just processed. I'm going to open the attribute table just to once again kind of familiarize you with what we've done. We have our counties for 2016, and for each county, we have the votes that went to each candidate in 2016, votes Democrat, votes Republican, total votes. And more crucially, we have this voter turnout field, a value between 0 and 1 that reflects how many people in that county voted that could have voted. So one thing that I may want to do is symbolize the map by those values, right? So I'm not sure yet how to symbolize it. So the first thing that I often recommend is create a histogram. And a histogram is just going to show you the range of the values there. So I'm going to specify, I'll really care about voter turnout. And right away, I've created this histogram basically showing you the distribution of voter turnout values. It's pretty normally distributed. I can make a selection here and it'll highlight them here on the map. So here's the counties that essentially voted really high or had high voter participation. Here's the counties that voted really low. But just selecting on the chart and seeing them on the map doesn't really give me a good sense of what's happening. So I definitely want to symbolize by that value. And I'm going to select that. Because it's normally distributed, we can symbolize using standard deviations. And we're getting into some stats, but don't worry if you haven't familiarized too much with it. If you're already a pro, then great. So I'm going to use graduated colors. I'm going to specify voter turnout as the field that we want to symbolize by. And I'm going to change the color a little bit. Since it's standard deviation, since it's normally distributed, we can display it by 2 colors. Basically, one color showing the places that have really high voter turnout, and one color to show the places that have low voter turnout. So I'm going to select standard deviation, and I'm going to check the color scheme. Let's go ahead and select something that diverges a little bit, something more like this. And there's a little trick here. If you use ArcGIS Pro, there's this little hidden option here where you can apply that symbology not just to the inside of the polygon, but you can apply it to the fill as well. And it gives you this neat effect where it's kind of a bit clearer to see the patterns. So here's voter turnout for the 2016 election. The counties in green essentially voted really well, at least compared to the rest of the country. So you start to see some, just visually, you almost see entire states stand out, right? Colorado to me stands bright green. They had high voter participation. Same with Minnesota, Maine, New Hampshire. Some of those states really have kind of high civic participation and a lot of voter participation. The counties in purple didn't vote or didn't vote as well. Tennessee, West Virginia, if I turn off the state outlines, you can almost see them just outlined by the sheer patterns of voter participation, which is really interesting to me. So this starts to get into some interesting questions, right? Why is Tennessee voting so low? Why are parts of West Virginia voting so low? New York State is really interesting. Obviously, it has New York City, and there's a particular pattern expected there. But in northern New York State, you see this really low voter participation, likely people that perhaps don't feel their votes count on behalf of the city that has a much higher voter participation. So something else you may want to do at this point, we've created a basic map. We may want to continue interrogating state by state. So I'm going to create a bar chart. And for this bar chart, we're going to select our category to be the state. And we want to get the average voter turnout by state. And believe it or not, we don't have to calculate that in the table. We can have the chart do it for us. So we're going to do that here. I'm also going to stack rank it ascending order. And what we're looking at here now is we're looking at this. Yeah, let's keep it like that. We're looking at this bar chart showing us kind of a lot about each state. We can see that, for instance, West Virginia is the second lowest state in terms of average voter turnout. Tennessee, third lowest. Arkansas, fourth lowest. Oklahoma, fifth lowest. And then on the other end of the spectrum, Colorado indeed has the highest voter participation in this data, followed by New Hampshire, followed by Minnesota, or Maine rather. I think Minnesota is shortly behind. So that's state by state assessments, right? You can start to see kind of where your state may rank. However, that doesn't really tell the full story, right? Even within states, there's these little mini stories, particularly Texas, for example. I mean, Texas is a gigantic state. And you can see that there are some counties that voted really well, even if Texas as a whole perhaps didn't vote terribly well. It's sixth lowest. So something you may assess there if you're exploring this type of data is you may want to create a box plot. And a box plot, let's go ahead and create a basic one first to start. So a box plot, we're going to select voter turnout as the field we care about. And I'm going to create a basic box plot just for the entire country just to start. This, if you're not familiar with box plots, don't worry, they're simple. It's basically a way to assess, it's kind of like your histogram turned on its side. It gives you the average voter turnout, and then it gives you these whiskers basically with the distribution of all the voter turnout counties. But I'm going to split it by state, and this is kind of where it becomes really powerful. So actually category is going to be state. There we go. And I'm going to have it show outliers. And this is where it gets really, really interesting. So if we select something like Texas, Texas is right here. If we select this box plot, we can see it reflected here on the map, but we can also select just these outliers and we start to get a sense of basically the distribution and which counties within that state are outliers for that distribution, right? And makes me wonder what's happening there in Texas, right? What's happening that makes those counties vote so much better than their peers? Similarly, I think to me, the outlier that stands out the most nationally is this one little dot. I hope you can see it. And this reflects a county in Georgia that is the extreme outlier, not just for Georgia, but the entire country. So this, if we zoom way in, this is called Chattahoochee County, or I'm so sorry, Chattahoochee. And I've butchered the name of the county, but there is an interesting blog post called "The County Where Almost Nobody Votes." And this gets into Chattahoochee County's history, why it votes so low, ignore the advertising, but really gets into this really interesting story about the county basically being the site of a military base. Most people don't live in the county, they just work there. And there's a low denominator problem and kind of low civic participation there that results in this county having the lowest voter participation in the entire country. But just through your data, just through visualizing and exploring your data, this is kind of how it's reflected. You start to see these stories bubble up, which is one of my favorite parts of it all, right? Additionally, what we can do, we can get into some neat tricks. Let me show you one. Especially if you use ArcGIS Pro, you may want to learn about this. One trick is that I may dock these charts in this manner. And right over here, I'm going to change this bar chart. Instead of looking at it state by state, we're going to look at it county by county. So it's a lot of records. And it's going to look a little bit like a mess. Since it's a county level, we don't need to show the average. We just need to show the raw voter turnout for that county. And we see all the counties stacked up here. We can make a selection and see them selected in the map. But actually what I want to do is create an extent or a selection filter. And it kind of behaves like a dashboard. So now I can select Georgia, for example, and see just the counties for Georgia reflected in that bar chart. Or I can select Texas or South Dakota rather, and see the counties just for South Dakota and see which counties basically are in that distribution. So you can continue exploring this way, basically assess for your particular area, how are the counties doing? Colorado's pretty good, as you can see, mostly green. but there's other areas that may have some challenges, right? So Arkansas and its low voter participation counties. So we've gotten pretty far. I basically now I'm curious, what is causing low voter turnout? And this gets into some interesting things about relationships. So what is related to voter turnout? And for that, we can create a scatter plot. A scatter plot looks at not just voter turnout, but looks at the relationship of voter turnout with some other characteristic of interest. For example, something like on the x-axis, let's put median age. I'm really curious, do old people vote better than young people? Very often that's the case. So let's see if that's reflected in the data. So we're creating a scatter plot here. Once again, we can select a particular area of the scatter plot and see it reflected here. An R-squared is sort of a measurement of your relationship, and this one isn't particularly strong. So I'm gonna change this field. Maybe my assessment now is maybe age isn't a strong predictor. Maybe per capita income is. And in fact, per capita income is a much stronger predictor of voter turnout. And of course, the old saying applies. Correlation doesn't imply causation, but nevertheless, I am curious about this relationship. And what I'm going to do is, so nationally, there is a somewhat, it's pretty weak, but it's still interesting of a relationship, 0.34. What we can do is set an extent filter. And what this lets you do is basically use your map extent and update the chart just using your map extent. And what's interesting about that is I'm zooming in here to Florida, and I want you to pay attention to this R-squared. It's gone all the way up to almost 0.6. What that means is that in Florida, per capita income has a really strong relationship with voter turnout. Now, if I zoom back out or go up to Georgia, the relationship weakens. It's not quite as strong of a predictor. If I go up to Virginia, it gets a little strong again, 0.47. So this mechanism of setting your extent filter, looking at your chart, looking at the R-squared, and navigating the map, now that becomes a powerful tool to see where the relationships are strong. But it's still a pain in the rear to do this and really get to some key takeaways, right? So I'm gonna show you one last thing tonight. And this last thing is gonna get into spatial statistics and kind of the heart of what I love to do. So we have a tool called local bivariate relationships. And this tool is really meant to work with that concept that those relationships change across geography, across space. And there's this saying that basically the measurement of a relationship between two variables, voter participation and your income, or X and Y, anything that you may care about, really depends on where that measurement is taken. So the tool will take these two input variables. It will determine the significance and type of the relationship and give you a map of entropy. Basically the map of those relationships and how strong they are across your geography. And I'm going to get just a little bit into it because I think it's pretty interesting to learn about how these tools work behind the scenes before you use it so that you can defend what you're making, right? And I'm going to quickly just cover what does it mean to be related. You may have these good relationships where one variable is a strong predictor of the other, kind of like what we saw with per capita income, particularly in Florida, right? But you may have null relationships. I don't want to say they're bad because they're not necessarily indicating too much about the outcome, but they're just not useful for our purposes. There's no perceived relationship. And the interesting thing here is that, as it turns out, there's this thing called entropy that can be a strong measurement of these relationships, whether they're good or null. Low entropy means that you have really good relationships. High entropy means that you have kind of problematic relationships that don't help that much. And the reason why that works is because of entropy and how it works behind the scenes. So it's not exactly like this, but I like this visualization just to kind of wrap your head around entropy. And in thermodynamics, you may think of particles, right? And entropy being a descriptor of chaos in those particles, how much they move. So low entropy would be something nice and calm and steady, where these particles are just kind of gradually moving back and forth in predictable patterns. Low entropy means high predictability. You know where things are. Now let's spike up the entropy. Things get chaotic, things are moving around, and it's a lot harder to predict where any given particle is going to be just a few seconds from now, right? So that concept applies here. You may have two variables with their independent entropies, but what someone found out at some point is that you may have shared entropy, basically meaning that this chaos is shared between these two variables. And when taken together, the entropy may tell you something about the other variable. And that's powerful because that can apply even if you have a really complex relationship, even something that's not linear or quadratic or basic. And that's called mutual information or information gain. So the way we measure it is through something called minimum spanning trees. Those minimum spanning trees essentially amount to that entropy measurement. A low total for minimum spanning trees corresponds to low entropy, a high corresponds to higher entropy. And then we do statistical checks for the relationships. Basically, we try to assess, is this feature significantly related? And if it is, we'll try to classify the relationship within a neighborhood of that feature. So for each county, we're going to create a small local area. And for that local area, we're going to try to do that entropy check. And if it is significant, we're going to check basically the entropy values and check if they're independent from each other. And if they are, we're going to compare it with a synthetic distribution of these entropies and change them up a little bit and try to assess what is the world. We're going to check a null hypothesis, basically. In what world do we live in where this entropy exists? And if I keep going a little bit here, I'm going to skip a few slides just for the sake of showing you the output map since we're running a little bit short on time. But what I want to get to is basically this check that in this neighborhood, we're going to get this measured entropy and we're going to measure it against a world where these two variables aren't related. This is the key takeaway. So if our entropy is really unlikely in a world where these two variables aren't related, then our p-values are going to be really low. And this gets back to basically statistics, right? And if that's the case, then our map can classify that relationship, check if it's positive linear, negative linear, convex, concave, or maybe something way too complex to just describe in simple terms, or just as importantly, tell you that they're not significant. And by that measure, then we can basically get our map. So I'm gonna come back to our map. I know we went down the deep rabbit hole of statistics for a brief second. I just wanted you to peek briefly at how that tool works behind the scenes. And now we're gonna simplify it. We're going to run it here in real time. And the tool, as I mentioned, it's called Local Bivariate Relationships. It can be found under Spatial Statistics tools, under Modeling Spatial Relationships. And as complex as all of that may have been, running the tool is really simple. All we have to do is basically pass it our input, specify our dependent variable. Our dependent is what we want to predict or try to assess relationships for. That's voter turnout. Our explanatory variable, the thing we want to measure for relationships, is going to be our per capita income. And then we're going to let the tool run. Everything else is basically optional to some degree, or at least for a first run it is. And then the tool will give us an assessment of how those relationships permeate across the country. So let's take a look at our outputs. I'm going to turn this off. And actually, I'm going to change this output coordinate system to correspond to our map so that we can make the outputs render a little bit faster. All right, we should get our outputs here shortly. And by the way, one quick note, if you're just getting acquainted with analysis tools like this, my biggest tip is click this little question mark. It takes you to our documentation page. And our documentation page takes you in detail through how all of our data science tools work, essentially. So here's our output. We get this interesting result where we get relationships that are positive linear, negative linear, concave, convex, undefined complex, or not significant. So what really stands out to me is this pink, right? The areas in pink essentially mean that there's a really strong relationship between per capita income and voter turnout. So Florida, it's kind of all colored. And if I zoom out here a little bit, let me make this pop up a little bit larger. I just selected a county here in Florida, and basically we're assessing for that particular county, for that relationship, what is its neighborhood like? And that gives us a sense of basically where that predictor can be really powerful for some other process that we may want to apply. And in short, this is a map of relationships, right? This is a map of relationships between income and voter turnout. And by that same measure, we can quickly change it to model something like median age. Let's go ahead and run that. Becomes pretty addicting just to try to assess what those relationships are across space, because it's pretty easy to find data for any particular variable, right? Whether it's income or your propensity to watch Netflix, things like that, believe it or not, are pretty easy to find these days. So here's a map of the relationships between your age and your voter turnout. So what this tells me is that the Midwest, or really the Great Plains, Montana, North Dakota, South Dakota, Wyoming, there's a pretty strong relationship between median age and voter participation. So in these counties, the older you are, the more you participate, or in the areas around here. Same with parts of Texas, or same with parts of Kansas. And if you recall, we had seen Texas having this pattern of these few counties that participated really well in spite of most of the state not participating that well. And likely that's these older counties, very few people that are very old, or generally much older than the typical county, participate pretty well there. And that starts to get into the why, right? Or at least hypothesizing the why. And let's do one more just for fun. Let's do, just to have a quick laugh, we have a variable for people in that county that own a selfie stick. Believe it or not, that's a variable that is tracked. So if we're checking how strong of a predictor is owning a selfie stick versus participating in an election, let's see what that map looks like. So we should get the output here shortly. And that's just to prove the point, not every relationship should be trusted. There are some strong relationships, believe it or not, between owning a selfie stick and voting, but there's likely these other confounding factors, right? I think a lot of people that own a selfie stick typically travel, and people that typically travel may have a propensity, maybe higher income and things like that. So this map doesn't give me a general pattern. I mean, Florida is actually kind of the strongest thing I see here, that there is a statistically valid relationship, but just because you see it, you do kind of still have to be a human and an analyst first and foremost, and ask the question, can I use this variable in my predictive analysis? And the answer likely should be no. Even though there is a sense of a relationship there, maybe you shouldn't use that variable. So that's a whirlwind tour of a lot of content. I'm going to skip a few slides here and wrap up. I do want to point you to some resources. These are some URLs, first and foremost, for our spatial statistics teams, tools and presentations. That's esriurl.com/spatialstats. Everything I demonstrated and a lot of other interesting demonstrations that relate to prediction, to clustering, to machine learning. You can find these presentations there, and a lot of content can be actually gathered there if you're looking to keep learning about things like this. Similarly, in October, actually we're right in October, but at the end of the month, we have a free Mooc. And this Mooc basically is my, if I needed to recommend, how do you get started with something like this? How do you keep going down this path of being an analyst or applying spatial data science for your work? The Mooc is likely the best way to do this. And particularly because everything we showed here, the notebook that prepared this data, the analysis, even going farther and doing some actual predictive analysis, applying it to this upcoming election, is covered in this Mooc. So sign up for this. It's free, starts on October 28th, goes through December 9th. And hopefully you have some fun doing it. And finally, there's something we refer to as the ArcGIS Bridge. Many statisticians, many data scientists, people that work with machine learning, work with R. And we do support a lot of work in R. And you can navigate to esriurl.com/r ArcGIS Bridge to see some of what we've produced there. So that is a lot of content in a short time. I hope that you had some fun. I hope that maybe on a replay or looking at the notebooks at your own pace or at the tools at your own pace, that you're able to work with this. And as a brief reminder, please vote in the upcoming election. Again, thank you for joining us today, and maybe we can open it up for some conversation.
Yeah, so Alberto, we had a couple questions. I was just wondering, I mean, that was amazing. You covered a lot of stuff. I was wondering, could you just do like a quick 2-minute summary of what we saw now that we've seen it? Like, I was trying to track it, but the way that I was looking at it is it looks like you were using Python a lot for your data preparation, your wrangling. You brought in data outside of non-GIS data, and then you started looping in some of the Esri data, bringing that together, and then you started doing a lot of work in this tool, the ArcGIS Pro. I was just wondering if you could just summarize like what you did real quick, just so that I can think about what I just saw.
Yeah, absolutely. It was a whirlwind tour. So I would summarize it as these 3 steps. We started with Python, and Python was really just our tool to prepare and clean up some data, right? It basically was just really useful from the notebook perspective to kind of write down what we needed to do to check some data issues, to prepare it and check for some things. Then we brought it into ArcGIS Pro, which is a desktop GIS. And this lets you quickly create maps. It lets you use statistics tools or machine learning tools and apply some techniques to quickly visualize and explore your data. And we did that with some charts, right? We started creating some charts that relate to the voter participation state by state. We looked at voter participation county by county. We also started looking at then relationships between, okay, why is voter turnout so low here, so high there? And that's when we started getting into, okay, we can create a scatter plot that looks at how strong that relationship is in parts of the country, but that's kind of hard to do manually, right? So that takes us to the final piece, which is the most complex. And I think that part I rushed through, but that's spatial statistics. And there was one tool I ran called local bivariate relationships. And that tool is basically what summarized the strength of the relationships versus voter turnout. And the goal there is just to prepare you for machine learning or statistical regression, techniques that help you build a predictive model for voter participation. And to maybe wrap it up and put it on the real world again, the idea is that if you really care about having high voter turnout in an upcoming election, you maybe want to predict or build a model that looks at, okay, what factors led to low voter turnout and high voter turnout in the past? And can I model those well enough so that in the next election, there's high voter participation? And hopefully that summarizes it to some degree.
No, that was great. So I guess like you used that one reference of the selfie stick. So was
Yeah.
that in the MIT data or?
No. And I didn't cover that, but there is one piece that I'll briefly touch on. So let's rewind. So there is a tool called Enrich in our GIS. So basically this is our set of tools. We call them geoprocessing tools, but I'm gonna look for Enrich. So here's the tool. And what's interesting about Enrich is that basically it lets us browse variables that may be useful for our purposes. So things like population, the breakouts by generation, whether you're looking at millennials, baby boomers, or things like gender and gender breakouts by age, things like that. There's this rich wealth of data that you can kind of tap into. And what Enrich does is it lets you select some of these variables. And for each county, it's going to calculate how many for that variable can we find in that county so that we can then use it for predictive modeling or some other purpose. So that variable propensity to own a selfie stick, believe it or not, is one of the variables that we have in this data set. And that was morbid curiosity primarily.
But that's pretty cool. I mean, so like when you first started, you were utilizing the election data that you showed with MIT. And then it sounds like once you were able to get it into this tool, you're able to enrich it with other data sets. So you don't, I guess my point is you don't have to go back, redo all that work that you were doing in the notebook to join another data set to the data and resend it over.
Exactly.
One thing that Esri provides, we're a huge content provider. So in the chat window here, I sent a link to our Living Atlas. Maybe Alberto, maybe you can just pull that website up real quick, because that Living Atlas is actually a curated set. Actually, yeah, it's all this data in these categories here. And what Esri provides are base maps and imagery sets and kind of like a best of breed approach. But then we also aggregate a lot of the information from Census or HHS And we map that, and we have those as feature services. So not only can you visualize that data, but you can also get the actual attributes and the features of each one of those services. So you can add that to your Excel spreadsheet. And so that geo enrichment API that's in there, well, actually, we have a plugin for Microsoft Office and Excel. And so if you make a spreadsheet, you have like, voting locations, right? Polling locations in there, you can actually do drive time analysis for each one of those and add some of those variables that Alberto talked about, like selfie sticks or median age or whatever it is. And you can actually do like a 3, 5, 10-minute drive time from that location, or a distance buffer from that, right through that API, and it will add columns to your Excel spreadsheet. It's really powerful.
Yeah, I'm looking at some of the data he's clicking on. I'm just like, you could basically plot like who watches football to who voting and things.
Yeah.
Just through that, it looked like, right?
Yeah, I mean,
Yeah.
this is the same data that like Starbucks, Chick-fil-A, like Walgreens, they use this same data and program to figure out where they want to open and close stores, who their market relationships are. I mean, this is the same programs and some of the same data that they use. They may use a couple of other different variations or some other things, but the base data is all there. And we have another product called Business Analyst Online. It's really powerful. And you could do like site selection and market segment analysis, and you could do some really cool reporting and infographics from that, all from this data that Alberto is showing you here.
So another couple questions with the tools, I guess. Like you mentioned it, R. Do you guys have support for a lot of like R and Julia, and I mean even like Java, JavaScript? Do you kind of go across the board?
Yeah, I'll start there, and then Alberto, you can kind of finish them. So
Yeah.
I think one thing, Esri is a proprietary software platform, right? It's bought and used and licensed by a lot of these different companies. But I'll tell you, we do a lot of work internally and externally to make sure our platform is open and interoperable. A lot of work, and that includes making sure we can integrate with other open systems and integrate with other platforms like R and Python. So Alberto, maybe you can walk through the R bridge here.
Yeah, and generally what it amounts to is very often if you're a statistician, if you're a data scientist for a company, you may already have your own R routines that you run for analysis, and you maybe want to tap into some of the data that we're talking about here. Maybe you want to bring a variable related to purchased an Xbox in the past year. And to do that, you can actually use this ArcGIS bridge to enrich, just like we did earlier, and then extract that out into an R data frame, and then join it to your R workflow and stay in R if that's what you prefer. Consequently, you can also start from ArcGIS. If you're a GIS practitioner, you may want to work here, and then you may want to tap into some of the R routines that do statistical analysis. R has this rich ecosystem of work, right? And we're not going to cover every single R routine in our tools, but if that's something that you want to do, then you can use the ArcGIS bridge from GIS to tap into some R routine. So it's kind of like a two-way bridge, right? From, if you prefer R, you can bring in some GIS flavor to your work. If you prefer GIS, you can bring in some R flavor to your work.
Yeah, that's really cool. So, I mean, we're getting a couple questions, but I'm kind of going to put them all together. And you kind of alluded to this. There's always the questions of how you get started, like suggestions. And at the very beginning, you mentioned Pandas, and you've shown the online learning class that you guys have and all the resources. I guess, is there anything else that you would speak to? Like there was a question of like how to really get started with Python, but I guess my question would be like, would you recommend Python be the language that people are using? Is there a natural progression here? Like learn Python, learn Pandas, jump in, work with the data the way that you were kind of doing it, take that class. Is that kind of what you would suggest?
Yeah, I'll give you my 2 cents, and that's maybe just advice, and take it with a grain of salt, take it in conjunction with other advice. Really think about what you're trying to do, right? First, if you work for an organization, think about what they're trying to do generally, and then work backwards from there. I think a lot of people Like the reason I say that is because a lot of people are sort of gravitating towards AI, machine learning, and of course those things are powerful. They are important and needed. But to some degree, the purpose of that work is lost. Very often people are saying, I need machine learning. And then we go, well, to do what? And their answer is, I don't know. I just know I need machine learning. So that often guides people to sort of spending a lot of time learning something, and then ultimately it doesn't come to fruition. So that soapbox aside, my point there is really think about the type of work you're doing or that you want to do. And then for that type of work, generally, there's a lot of approaches. I found Python to be really, really powerful. And it's for quite a few reasons. It's easy to write, it's easy to learn. It's multi-purpose. It's not just for data scientists, not just for statisticians, it's for DevOps engineers, it's for any general scripting process. And the ecosystem is growing exponentially every year. It seems like you can find examples and notebooks and literature that really help you quickly catch up to some task. Googling for some how to do X or how to do Y usually yields pretty good returns for Python. R, I don't want to dismiss R at all. In fact, I want to celebrate it because there is a very rich statistical ecosystem in R, and some of the more impacting work I've seen is through some of the R practitioners. So while I'm kind of taking the easy route off by saying it depends, it really does. A lot of, if your organization happens to use a lot of R, maybe it's more important for you to learn R so that you can collaborate with your peers, right? And then finally, I do, take it with a grain of salt. I work at Esri, but at GIS, especially something like ArcGIS Pro, what you're seeing here, is valuable. And I hope I proved some of that value today. There's data exploration, map making, and statistical analysis that may or may not include machine learning that you can do just from this workstation. And we do a lot of work to make it accessible. So the point there is that you may not know Python, but you should still be able to apply what you know about your domain to answering questions. And generally, we try to make those tools accessible. You can build a machine learning predictive model without knowing Python by running some of our spatial statistics tools, for example. So really convoluted answer, but it's a complex question, right? And I think each person has to find their own path and story, and that's maybe the best way I can answer.
No, I thought that was a really good answer, and it's interesting to see how powerful some of the tools are, and I liked how you were able to go in between. So that's pretty awesome. So, I mean, that was it. That kind of wraps it up. I think actually I thought that was really awesome. I mean, I didn't really fully appreciate the GIS data until you showed all that and the way you were able to bring it together. I can definitely see the power there. You sent a lot of resources. I'm going to try to get the resources posted to the meetup page. The video will be up. We'll clean it up a little bit. If you guys have any questions, I think you can probably reach out to Anthony and Alberto if you have questions about the products and the company and all those things. If you look at their website, they have a tremendous amount of information there. Even like the documentation you pulled up, like you clicked on that one link and you had the pretty elaborate documentation of how to use certain features and stuff. That's pretty awesome. And then the class looks like it's going to be pretty cool. I actually might sign up for that one. So
great.
Yeah, we'll get like 30,000 people to that class. So I mean, it's very popular.
Yeah. And my favorite part of the class, really quick, was the interaction between the people taking it. We have our lessons and everything, and there's like a week by week you achieve certain things. But at the end of each week, you present your results, you show your maps, your analysis, and then others comment. And really, some people were able to go far beyond the class and improve on what we put together. And
cool.
That was my favorite part of it all. So go in and show us what you can do.
Yeah, that's awesome. And there was a quick question about the Python notebook. I think you guys did share it. Yeah, I thought you sent the link, Anthony. So there you go. And I'll try to capture that and put it on the meetup page for people that are on the YouTube channel. So with that, I mean, I'm gonna close it up. I really appreciate Anthony and Alberto, you guys taking the time. You guys did an amazing job. I thank everyone for joining in. I hope to see you guys at the next event. And if you guys have any questions, you can reach out to me, or you can reach out to Alberto and Anthony if you have questions about what they had presented. So with that,
very cool. Thank you.
Thank you.
Thank you, Jason.
Good night.
Appreciate it.
Yes. See you guys.
Thank you
All
so
right.
much. Bye, everyone.
Great job.
Bye.